Hello and welcome to podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or you want to try a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With 200 gigabit private networking, scalable shared block storage, node balancers, and a 40 gigabit public network, all controlled by a brand new API, you've got everything you need to scale up. And for your tasks that need fast computation, such as training machine learning models, they just launched dedicated CPU instances. Go to pythonpodcast.com/linode, that's Linode, today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. And you listen to this show to learn and stay up to date with the ways that Python is being used, including the latest in machine learning and data analysis. For even more opportunities to meet, listen, and learn from your peers, you don't want to miss out on this year's conference season. We have partnered with organizations such as Dataversity, Corinium Global Intelligence, Alluxio, and Data Council. Upcoming events include the combined events of the Data Architecture Summit and Graph Forum, the Data Orchestration Summit, and Data Council in New York City. Go to pythonpodcast.com/conferences today to learn more about these and other events, and take advantage of our partner discounts to save money when you register. Your host, as usual, is Tobias Macy, and today I'm interviewing Antoine Fourmy about eNMS, an enterprise-grade, vendor-agnostic network automation platform. So, Antoine, can you start by introducing yourself?
Yeah, sure. So my name is Antoine Fourmy. I started my career as a network engineer. So I worked for Alcatel-Lucent, a company that sells network equipment to service providers. Then I worked for the two main internet service providers in France, Bouygues Telecom and Orange. And I slowly made the shift to network automation, so using Python more and more for my day job and libraries such as NetMiko and Napalm that we use in the network automation field. Last year, I decided to quit my job at Orange and to focus on creating my own network automation platform called eNMS. And that's what I've been doing up until now. So I'm working as a full-time maintainer for the eNMS project on GitHub.
And do you remember how you first got introduced to Python?
Yeah, I started using Python when I was in high school. So that was like 15 years ago. I was using it for a website called Project Euler, which I think still exists, where you can solve mathematical challenges about prime numbers and so on. Yeah, I was using it mostly for fun back then, but for the past 5 years, I've been using it basically every day for work.
And so you mentioned that you started working on eNMS fairly recently and you're doing it full time. I'm wondering if you can start by giving an overview about what the project is.
Yeah, so eNMS is a network automation platform. Basically, a network works with many different types of devices, such as routers, switches, firewall, load balancers. And all these devices are very different from each other, and they are very different from a traditional Windows or Unix server. They have like a custom operating system and different requirements in terms of memory and security. So the process of automating them is very different from standard server automation. So that's what network automation is all about automating these network devices. This can mean like very different thing like configuration management. eNMS can keep track of all your configurations, but also automate the configuration lifecycle, like pushing changes in an automated fashion, storing configurations in Git and so on. It can be used to perform automatic device upgrade. It can be used for event-driven automation as well. So like I said, it's a web platform, so it uses a number of libraries. NetMiko is like a Python library that is built on Paramiko and that we use to SSH to a network device. It uses Ansible, so it can detect your playbooks on your computer and let you run them from the graphical interface. It uses requests as well if you want to send calls to a remote REST API, and it can turn any Python script into a graphical form. So if you have like a Python script that you would like to use and this Python script can take input parameters. eNMS can take care of converting this script into an HTML form with drop-down list, checkbox, and so on for you to use it in the GUI. And this is all done graphically, so you don't have to code anything by yourself if you don't want to. And it lets you create these different bricks and assemble them into a workflow. So this is a workflow creation platform.
So I'm wondering what your motivation was for creating it, and particularly since you decided to leave your previous employer to focus on it full time.
Well, there's been like a long-standing disconnect between the network engineering world and the software engineering world. So network engineers are usually not software savvy, and software engineers are not very network savvy as well. So I guess the main idea behind eNMS is to try bridging that gap by allowing network engineers to automate a network without having to be an expert at programming. So making automation graphical and bridging the gap between software engineering and network engineering. That was the main motivation. Plus the fact that, I was working as a network automation engineer at my previous job, so I had to use tools like eNMS, but I felt like they were not doing the job properly. They were very, very cumbersome to use. So I decided to fill a void by creating a different application.
And for people who are working in that space, I know that there are a number of other tools that serve to do things such as monitoring the network or manage the inventory. So tools like OpenNMS is one that I've used and am familiar with. And I noticed in the documentation that you have some integration for being able to cooperate with that. So I'm just curious, what are some of the other tools that exist in this space, and why you thought it was necessary to create a new one in terms of what might have been lacking in those tools and ways that eNMS fits into the broader ecosystem?
I would say there aren't many tools like eNMS because the main focus is network automation. And in the network automation field, there isn't many tools like that. So you just mentioned OpenNMS, but OpenNMS and LibreNMS are more like network monitoring tools. So there are tools that you can import your network topology and then let the application monitor them and draw graphs about how much traffic there is. But they are not used for network automation. So I'm basically just interfacing with them because the people who use eNMS are also using these tools, and they have imported their topology into these tools. So I'm basically just using the REST API to retrieve the topology. So there are a bunch of tools that are similar to eNMS, but not quite. So you have Ansible Tower and Rundeck that you can use to run Ansible playbook, but the downside is that it's limited to Ansible. So you have to use Ansible if you want to use Ansible Tower. You have also tools like SoulStack and StackStorm, but they were created mainly for server automation as opposed to network automation. So basically the fact that network devices have custom operating system and work differently makes tools such as SoulStack very difficult to use for network automation. In the case in SoulStack case, they are basically installing what they call a minion, and for that they need access to the machines. They need to be able to install something on the device, which you cannot do on a traditional network device. So they came up with a solution called Salt Proxy Minion, but that's basically just a hack to make network automation possible, and that's not what they were designed to do in the first place. So you do have some solutions to automate network, like open source solution, but usually it wasn't created like as a first intent. It was created for server automation, and then they tried network automation as well, but it doesn't always work very well. And of course, you have proprietary softwares as well, but then you have to pay for it. And if you use like a Cisco software to automate your network, you you will only be able to use it to automate Cisco devices usually. So what set eNMS apart is that it's a multi-vendor tool. So it doesn't matter if you're like using Cisco or Juniper or Arista. It doesn't matter what your network is made of. It will be able to automate everything just the same.
And you mentioned earlier that the community of network engineers isn't generally very well versed in software engineering, and software engineers aren't generally very well versed in network management. So I'm curious who the target users are for eNMS and what sorts of design elements you're incorporating to make it easier for them to be able to achieve the goal of managing these distributed networks.
So the target users are service providers. So companies with a very big network and thousands of network devices, routers, switches. The more network devices you have, the more automation you need to manage your network. So this is the scale that I'm targeting, like when you have thousands of devices. And what eNMS is doing to make automation easier for network engineers is that it's so graphical. So you have these Python libraries, NetMiko and Napalm. You have Ansible as well. You don't need to code anything by yourself. You just need to create like what we call a service in eNMS. It's basically just an HTML form that you have to fill and to tell eNMS what you want to do. And eNMS will take care of interfacing with the libraries, NetMiko or Napalm. It will take care of connecting to the network device. It will take care of storing the credentials as well, because you don't want to have credentials out there in the open. So eNMS will store credentials in a HashiCorp vault. So this is the kind of thing that would be difficult for most network engineers, and that eNMS can take care of. So all graphical, creating workflows like from the graphical interface and creating automation task again by just filling an HTML form.
And networking, in large part, has become mostly invisible to end users and even software engineers because of things like the accessibility of cloud environments and things such as software-defined networking. So I'm curious what your perspective is on the current state of the industry and how broad the requirement is for people to be able to have a good understanding of networking and network management.
I don't think software-defined networking is such a big thing. Like, I mean, it's a term that you would have to define because it's used like it's mostly a marketing term, I'd say. It's not clear what software-defined marketing refers to. In a way, you could say that what eNMS does, and what the Python libraries such as NetMiko and Napalm do, is a kind of software-defined marketing networking.
I think you got it right. It's definitely more of a marketing term and one that has sort of fallen out of general use. I think it was more popular when OpenStack was starting to rise in prominence because that's what they were trying to use as far as being able to define the interconnects between the different resources and the cloud environment that they were building. And now that OpenStack is starting to fall by the wayside, people aren't really using that terminology much anymore.
Yeah, software-defined networking could mean something like you have some solution where you don't have to manage your network anymore. Like you take a software, and this software will take care of managing your network for you. But what this means is that you're basically outsourcing your network to a third-party software that you don't have control over. So this is something that can be useful for a small company when network engineering is not like the main business, and it's just like something that you can afford to outsource. But if we're talking about service providers, this is just not something that you can do. Like a service provider cannot outsource the network because that's what they do as a business. So I don't think SDN applies to service providers network.
And so, in terms of eNMS itself, I'm wondering what are some of the most challenging aspects of network creation and maintenance and some of the ways that eNMS helps with making those more accessible and more maintainable in the long run?
So most challenging automation tasks that I've seen so far is upgrading a network device because upgrading a router or an optical switch is much more difficult than upgrading a server. It can take from 6 to 8 hours for just one device, or it can even span several days. And you need engineers to work basically full time on upgrading your device. So this is one of the very challenging aspects of network maintenance, and this is something that you can definitely model as a workflow because an upgrade is usually always the same series of steps. It will start with like pre-checks, and then you will have to transfer a file to the device. That file will be like the version you want to upgrade to. Then you will do the upgrade and you will reboot the device and you will do a bunch of post checks to make sure everything's fine. And this is something that you can model with a workflow, and something that eNMS can help you with. Then once you have the workflow all set up, you can just run it, like schedule it to run in the middle of the night, and that's it. You don't need an engineer anymore to make this all this manual pre-check, post-check, and upgrade. So yeah. And something else that you could do with eNMS as well is some event-driven automation. Like for instance, you have all this DDoS attack, and so you have to use DDoS auto remediation mechanism to remediate it. And this is something that eNMS can do for you as well. You could have a workflow that would take care of the DDoS auto remediation process. And when the attack starts, you can make a REST call to eNMS REST API, and the workflow will start, and it will start creating an access list on a bunch of devices or this kind of automated task.
And having the workflow defined like that, I'm sure reduces the overall error rate for these types of operations, particularly since if something does fail at some point, you can incorporate that back into the workflow so that you can account for it next time. And so I'm curious too how you approach things like testing or validation of those workflows without necessarily having a negative impact on a live network.
Well, you test them in a lab. Like every service provider has like a lab dedicated to testing upgrades. It doesn't even matter that you're like using eNMS or not, that you are trying to automate it or not. Even when you're not trying to automate the upgrade, you have like a mob, and you will first try the upgrade on the lab device, and you will try it like a lot of times until you're sure that it works well. And only when it works, you will start doing it in production. So in eNMS, it would be exactly the same. Like you would have a lab instance and you would have a production instance. And you would first create a workflow on the lab. You would test it on the lab, and when you feel it's ready, then you would try it in production. From that perspective, there is no difference between making it like in an automated fashion or not. It's like first lab environment and then production environment.
I'm also curious how you approach testing of eNMS itself in order to remove that as a potential failure point for people who are running these mission critical networks.
I've got like many regression workflow. So, I've got regression tests as well and regression workflow. So every time I implement something new, like a new feature for the workflow system, I create a workflow in eNMS, and this workflow runs as part of Travis CI/CD. So every time I push a commit to GitHub, it will start running all my regression test workflow and make sure that everything works as intended. I'm also testing eNMS on virtual devices. So I've got like a virtual box, and I'm using a virtual Arista router, because Arista is one of the few companies that where you can download the virtual operating system. And that's very useful for automated testing. So I've got this virtual Arista device, and every time I make a new release, all the workflow will run against it. And if anything goes wrong, it will fail, and I will fix it.
Yeah, given that you're targeting physical devices and hardware environments, I'm sure that introduces a lot of complexity in terms of your development cycle, and also the fact that there is the potential for hardware faults in the overall deployment and maintenance of these networks. That introduces another layer of complexity that you wouldn't necessarily be able to handle with eNMS. And so I'm curious if that's where other tools such as OpenNMS and things like that would come into play, as far as being able to identify instances and switches that need to have some sort of preventive maintenance done to avoid those types of switches in these large networks.
I'm not sure. I'm not an OpenNMS user myself, so I'm not sure it would do that. Yeah, what's sure is that if you are running a workflow and it has an impact in the production network, you have tools, monitoring tools, that they would see it. You would see a drop in traffic or something like that. But I guess the idea is that this would also be part of the post checks of the workflow in eNMS. So if you run a workflow, you have a bunch of post check, and one of them would be to check that the traffic is coming back up after the upgrade or after whatever you did. So this is something that ideally, if something goes wrong, you should see in eNMS as well, because the workflow would usually include a rollback procedure. So if something goes wrong, you would have like a failure edge to some other part of the workflow that would take care of reverting whatever change you made. So yeah, if something goes wrong, it's definitely something that you want to detect in eNMS, because it is up to eNMS to take care of the rollback.
And in terms of eNMS itself, you mentioned a number of the different libraries and frameworks that it relies on. And I'm curious how you've approached architecting it to make it easy to use and also easy for you to develop it, and just any of the ways that it has evolved since you first began working on it.
Do you want to talk about like the overall system architecture of eNMS, or specifically regarding, yeah?
Yes.
Okay. Well, so eNMS basically uses the Flask web framework. It has evolved a lot since I first started working on it. I started using Flask to develop it, and then I switched to Django because I didn't like Flask. And after a while, I switched from Django back to Flask. So yeah, it has evolved a lot. It's very different from most Flask projects, because Flask is basically completely isolated from the main application. This is something that that you won't see in many Flask projects, because it's an unusual architecture. But basically, you have this controller application that takes care of all the business logic, and Flask is just used in eNMS as a way to process HTTP requests and nothing else. So I'm not using like many Flask extensions. I'm just using Flask itself and Flask login for the authentication, but that's about it. So Flask is used for the web framework. For the database, I'm using SQL Alchemy. So for creating the tables and for all the SQL requests. SQL Alchemy is like database agnostic, so you can use SQLite, Postgre, or MySQL. For scheduling tasks, I'm using AP Scheduler, which is one of the main Python library to schedule tasks. And I'm using HashiCorp Vault to store credentials. So the typical eNMS architecture would be the eNMS application itself, a MySQL database, and a Vault.
So for somebody who wants to run it on their own, there are a few different moving pieces. I'm curious if you have packaged up some deployment automation for that, or if that's part of the service that you're providing to support your overall development of eNMS.
I did use I have a Docker file in eNMS to deploy eNMS with a database, and as well I have a Docker Compose file as well, so you can run it and it will start eNMS with a Postgre database, but it doesn't create the vault itself. So this is not something that it's something that you have to do yourself. I'm not a big fan of Docker myself, so I did it just as a test. But I wouldn't recommend deploying eNMS with Docker. I would recommend creating the database yourself and setting up the vault yourself. So this is not something that is done automatically, but if you look at the documentation, I explain with a lot of details how to set up a Postgre database, a MySQL database, and how to set up a vault as well.
And then I'm also curious how you approach sustainability of the project and some of your motivation for creating it as an open source project, particularly given that you're targeting large enterprise organizations as the end users, and how that factors into their overall view of the project and any sort of sales cycles that you go through to start working with them.
So that's the kind of business related questions that I guess you have to start thinking about when you create a project. But that's not exactly what I did. I was just fed up with my job at some point, and I just decided to leave and work full time on eNMS, and I didn't have a clear plan in mind about how to make it sustainable. And I guess I was very lucky because I just started to have more and more users willing to pay for my maintaining the project. So I didn't have to do much. I guess again, I was lucky because users just came to me, service providers, and they were willing to contribute and to support the project financially. So.
And what have you found to be some of the most interesting or unexpected or challenging aspects of building and maintaining the eNMS project?
I guess the most challenging aspect is to build a community around the project. It's very hard to get people interested in what you're doing. So it's very strange because open source is basically like you're like offering a tool for free, and you would expect people to just care about it, but that's not what happens. And the most challenging part is to build that community and to make people interested in not just using it, but also contributing. That's definitely the most challenging part because, when it comes to just programming and implementing new features, this is something I can do. But at some point, as the project starts growing, you want to have, more people, more contributors, and more feedbacks. And that's the challenging part, I'd say.
And for anybody who does want to get involved, what are some of the types of skill sets and backgrounds that would be helpful both to you and also for them to be able to get up to speed and be effective at it?
eNMS is like 50% Python, 50% JavaScript. So if you want to contribute to the code base, the skill set you would need is like full stack programming, so knowledge of both Python and JavaScript. It's hard to do just backend or just front end. You usually need both. So I guess this is what makes attracting new contributors difficult because it's a very rare skill set. So Python, JavaScript if you want to contribute to the code base. But there are many other ways to contribute and to one of them is the documentation. It also takes a lot of time, probably just as much time as it does programming. So and you don't need any particular skill set to contribute to the documentation. You just need to use it and be willing to improve it. It just takes time, but anyone could contribute to the documentation or to the README.
And how much background knowledge of network infrastructure and network automation is necessary to be able to contribute for some of the more complicated bits?
You would need, it depends a lot on the contribution, on what you want to work on. You would need some knowledge about network automation, especially if you want to contribute something that has to do with NetMiko, Napalm, or Ansible. So you would need to have access to a network device so that you can test what you're doing. You need some networking knowledge as well if you want to contribute, because you need to test the code on actual devices.
And when is eNMS the wrong choice and you'd be better suited reaching for some of the underlying projects such as Napalm directly?
It depends a lot on your use case. eNMS is very focused on network automation. So if your use case is more like network monitoring, you would be better off with OpenNMS or LibreNMS. It's also not a network inventory tool. So if what you need is a tool to document your network very precisely down to the cable level, then you would need to use a tool like Netbox, which is a tool for IP address management and data center infrastructure management. So eNMS is like the right choice when you need network automation.
And what are some of the new features or improvements that you have planned for the future of the project?
I'm basically focusing right now on scalability, because I have more and more users with huge networks, like more than 10,000 devices. So the main issue right now with these big networks is to just make the project scalable. So there's two kinds of scalability. The vertical, what I'd say vertical scalability, like you want a single instance to scale up to 50,000 devices. And that means relying on server-side processing, so trying to not do everything in the front end, but rely more on the back end and the database. And you have like a horizontal scalability, which is when you deploy multiple instances of eNMS, you want to make sure they don't step on each other. You want to use a Redis database and something like Celery. So that's what I intend to add, like a task processing library along with a Redis database, so that multiple instances of eNMS can work together and share the load.
And are there any other aspects of the eNMS project or network automation in general that we didn't discuss yet that you would like to cover before we close out the show?
I think I don't know. I think that's it. I didn't add any other questions. So yeah, I think that's all.
All right. Well, for anybody who wants to follow along with the work that you're doing and get in touch, I'll have you add your preferred contact information to the show notes. And so with that, I'll move us into the picks. And this week I'm going to choose the Tedeschi Trucks Band. It's a group that I've been enjoying listening to that is actually the marriage of two different musicians who had their own bands, and they've now developed a new group that's actually a 15-piece band, so definitely worth checking out if you're looking for something new to listen to. And so with that, I'll pass it to you, Antoine. Do you have any picks this week?
I would just like to talk about Check.io. It's like a Python project to learn Python. It's a website where you can solve Python challenges online. And it's a very good website that I'm always advising to people who want to get better at Python. So I advise you to check it out. It's Check.io.
Yeah, I definitely will second that one. And I actually had one of the founders of the company on a while back, so I'll add a link to that episode as well. So definitely a great place to practice your Python skills. Well, thank you very much for taking the time today to join me and discuss the work that you've been doing with eNMS. It's an interesting project and one that has a lot of polish, so I'm sure that there's a lot of value that people are getting out of it. So thank you for all of your work on that, and I hope you enjoy the rest of your day.
Yeah, thanks. You too.
Thank you for listening. Don't forget to check out our other show, the Data Engineering Podcast, at dataengineeringpodcast.com for the latest on modern data management. And visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts@podcastinit.com with your story. To help other people find the show, please leave a review on iTunes and tell your friends and coworkers.